Hi, it's Tal from the lakeFS team. Today I'm going to show you a new feature called Metadata Search that accelerates dataset curation. Dataset curation usually starts with dataset discovery, the process of understanding what data you already have and identifying the data that you need right now. Discovery is then followed with dataset definition, where you assemble and formalize the curated dataset. But with massive collections of unstructured files like images or videos, discovery itself becomes a true challenge. These files usually come with metadata that provides critical context about the data, but using this metadata for filtering isn't straightforward. Without native metadata filtering capability, discovery becomes slow, fragmented, and nearly impossible to scale. In this video, we'll curate a dataset for a vision language model and see how lakeFS metadata search can streamline the entire process. Now, let's look at metadata search. Metadata search allows you to explore, filter, and curate large-scale unstructured datasets using SQL queries, all without setting up or maintaining a separate metadata store. How it works. Metadata search relies on lakeFS object metadata, and it automatically collects and indexes it. From here, you can either filter using system metadata, like object path, size, or timestamp, or search by user-defined metadata like annotations, labels, or custom metrics, as you can see here. In lakeFS, metadata is versioned alongside the data, so querying by metadata always returns results for the exact version you choose. The query interface is Iceberg-compatible clients, because under the hood, metadata search relies on lakeFS managed Iceberg tables. So let's see how metadata search helps accelerate data curation and simplify the overall process. To curate the dataset for the vision language model, we're using the 𝗶𝗁𝗏𝗏𝗏𝗏 image dataset that's intended for vision language understanding. We're working with a lakeFS repository that contains public domain images from the dataset and custom metadata fields that describe some aspects of the images like brightness, colorfulness, and more, and all are loaded as object metadata. Working with metadata search, this repo becomes SQL queryable by object metadata. So let's start curating some data. To avoid disrupting raw data and ensure consistency during curation, we will create an isolated branch. Let's call it Dataset Curation. Looking at our lakeFS repository and the branches it has, we can see that a Dataset Curation branch was created for us. The created branch gives us a stable snapshot for querying and sharing with others, even if main continues to change and evolve. For dataset curation, we will use PyIceberg as the client, along with DuckDB to run SQL queries over the object metadata Iceberg tables. We start with data discovery, trying to find relevant data. First, we would like to explore the available metadata and better understand which fields we can filter by, and what they can actually tell us about the data. Let's use pandas to inspect the image metadata. While inspecting the metadata, we can see what properties images of the 𝗶𝗁𝗏𝗏𝗏𝗏 dataset are assigned with and what's handy for us during data discovery. Now, let's dive into some specific image properties in order to curate a well-suited dataset for a vision language model. We can see that the images have an entropy score, which typically measures the amount of detail or complexity of an image. That sounds like an important property while searching for visually rich images. Let's explore it. One of the key advantages of lakeFS metadata search is that it makes it easy to inspect statistical properties of a dataset at scale using SQL and Python. We will now see how this can help us better understand what entropy means. I'm going to first load our metadata table so that we can use it. And now let's inspect entropy. For example, we can look at the distribution of entropy across the dataset, and it can help us later define the accurate thresholds to finding visually rich images. The results show us that most images have high entropy values, indicating that the dataset is a strong fit for our use case. Now, let's look at some image examples to better understand what entropy means. We're looking at images with low entropy score and high entropy score. Let's just look at some examples. These are images with low entropy score, pretty blurry, and another one, blurry, not visually rich. And on the other hand, some sample images with high entropy score are more clear, more rich, more visually descriptive. And another one. All right. To complete the data discovery process, we can analyze every other property images of this dataset have and decide on the right thresholds for our needs. Now, after we completed discovery, we can construct the curated dataset definition. And the best part is that we do that without copying any data. A dataset definition has two key parts. One is a SQL query that specifies the filters for selecting images. And second, a lakeFS tag that locks the query to an exact data version, ensuring query reproducibility. Here is our SQL query. You can see here that we've added a few more properties and thresholds to it. We can quickly validate its results and see that the curated dataset includes visually rich and clear images for the vision language model. We can see that we have this and that amount of images in our curated dataset, and let's just pick some images. Colorful, rich, easy to describe images. Another one. Okay, we're all set. Look like we're all set. So the next step is to make the SQL query reproducible, meaning to ensure that running the same query in the future will always return the same results, even if upstream data continues to evolve. Here's how we do it. We're first going to create a lakeFS tag. The lakeFS tag points to the head commit of the dataset curation branch. This tag locks in the exact dataset version we experimented with. Let's look at our lakeFS UI, and we can see that we have a VLU dataset tag that points to the head commit of our dataset curation branch. We can later use it. Now, second step is to run the SQL query against that tag, so results are always tied to that version. We do that by loading the metadata table using the tag reference, as you can see here. Instead of using the branch name, we're using the tag name. And finally, we're comparing the results of running the query against the branch and running the query against the tag. And as you can see here, data frames are equal. The final step would be to version the query itself in Git, just like any other piece of code. So what we have here is a different Python script we've created. And as you can see here, the Python script includes the SQL query that actually represents the dataset definition. And we have the curated dataset tag. And we make sure to load the table using this tag reference. So any other team member or future you that will run this query will always get the same results. With this, both your data version and your curated dataset definition are fully tracked and easily shareable. Let's recap. In this video, we've seen how metadata search accelerates data curation by letting you do faster data discovery, deepen the data exploration you're able to do, define curated datasets without copying data, and everything without building or maintaining metadata tracking and querying system. Want to try it out? Check the links below.